I'm Dr. Gress, and I just want to talk to you real briefly today about the paranasal sinuses. This is a little lesson that I always give in my labs when we're talking about the skull. So I just thought I'd go through these with you real quickly right now. In anatomy, the word sinus means an open space inside of another structure. And the paranasal sinuses are sets of cavities inside the skull bones. They're called paranasal because they all surround the nasal cavity. And in fact, they all connect to the nasal cavity. So we have 4 sets of paranasal sinuses. And I've got this model here. I can show you each of them. So this shows us 1/2 of the front of the skull. Right? So I've got this sort of face on here, and you can take that off, and then I can point out these paranasal sinuses to you. So first of all, we have inside the maxilla. If I take off part of the maxilla here, as well as part of the zygomatic bone, inside of the maxilla we have this large space called the maxillary sinus, and this is bilateral, so it's found on both sides of the skull and both your maxillary bones. If we look in the cross section, we can see the frontal sinuses, which are located above your eyebrows. So frontal sinuses on both sides above the eyebrows. In addition to that, on the inside of the skull here, we can see the sphenoid sinuses, which are these big cavities in the body of the sphenoid bone, here and here. And then if we remove the nasal conchae here of the ethmoid bone and look inside the middle part of the ethmoid bone, there are what are called the ethmoid sinuses, or sometimes they're referred to as ethmoid air cells. As you can see, they've sort of got a honeycomb appearance with spaces inside of them. So we've got these cavities or sinuses inside of the skull. I'm going to try to draw them on the skull I've got up on the board here. Just draw a couple of them. So we've got our frontal sinuses up here, something like this. And then we have our maxillary sinuses right here, which are the largest ones. And in fact, sometimes they're so large that the roots of the molar teeth actually go right up into the sinuses like that. And they probably be matching on both sides, symmetrical, so try to fix that a little bit right there. Now, all of these paranasal sinuses are lined with a mucous membrane, and that's what this pink stuff here is on this model. This is the mucosa or mucosal lining of the paranasal sinuses. So those mucosal membranes, they create mucus, they secrete a mucus, and that mucus is typically exits the sinuses through little canals that empty out into the nasal cavity. Okay, so typically the mucus that's generated from those mucosal membranes, actually the cells in that epithelia there in that mucosal membrane are ciliated, and so they can move that mucus out of sinuses and out into the nasal cavity where it drains out. Sometimes, if you have a cold or some other sort of infection, your mucosal linings all in your head start working overtime. Okay, so you get a runny nose, you might get a stuffy nose, and those nasal or paranasal sinuses can actually fill up with mucus and gunk. So this is not to be crude or anything, but if you've ever blown your nose when you had a cold and wondered where the heck did all that come from, my nose is not that big, it didn't actually come from your nose, that's mucus that was coming out of your paranasal sinuses. Now sometimes it happens that that mucus can't drain out well enough, maybe these little drainage channels get clogged, and then what can happen if you get bacteria in there is that you can get a sinus infection. So even just having these sinuses filled up with mucus can cause pressure, and that can give you a sinus headache if you've ever had a sinus headache. But if bacteria get in there and that stuff can't drain out, it can become infected. And then you've got a sinus infection. This is particularly common in the case of the maxillary sinuses. The reason for this is if you look at it, you notice where the drain is. Does that seem like a good place, a good design to you? Would you put the drain at the top of your bathtub? How well would that work out? So this is a big problem with the maxillary sinuses. For one thing, they're the largest ones. And for another thing, that canal that drains the mucus out is at the top. Normally, the ciliated cells on that mucous membrane can keep that mucus moving in the right direction, up and out, but if there's too much mucus in there, they can't keep up, and so it just builds up in there. And so the maxillary sinuses are particularly prone to infection. Why do we have the canal up at the top? My guess is that it has to do with the change in the shape of our face over time. So we have a fairly flat face, right? But of course, we started out as animals with a long snout. As that snout sort of got shorter and shorter, that canal got pushed up farther and farther towards the top. And now it's in this inconvenient position where it makes it difficult for those sinuses to drain. So what you should be asking yourself is, if we have so many problems from these sinuses, if we get sinus headaches and sinus infections, which, you know, without antibiotics, in the days before antibiotics, potentially could be fatal. Any kind of bacterial infection potentially could be fatal. Why do we have these things? What do they do for us? Well, there are a few answers to that. Probably the most important one is that this mucosal lining of our sinuses conditions the air that we breathe in through our noses. So the alveoli down in our lungs, the tiny little air sacs down in our lungs, are extremely delicate and easily damaged by particles in the air or by the wrong temperature of the air or the wrong humidity of the air. By the time the air gets down to our alveoli in our lungs, it should be pretty warm and pretty humid, and it shouldn't have particles, dust, and other things like smoke, things like that in it. So that mucosal lining of our sinuses helps to trap impurities that get in, and it also helps to warm and humidify the air before it goes down into our lungs. When we breathe out, it helps to reclaim some of that humidity before the air gets breathed out, so we don't lose too much water just through breathing. Another thing that you could think about is, what would be the alternative? So if we didn't have these paranasal sinuses, you know, what would we have here instead? And the answer, I suppose, is that we would have big solid chunks of bone. So our maxilla, for example, would just be one great big solid chunk of bone. Bone is pretty heavy. It's pretty heavy tissue. And so having all of that extra bone in our skulls would be a lot of extra work for our neck muscles to do, to hold our heads up and to move them around. So this is a way of lightening our skull and making our movements more efficient. Finally, and I don't know if this was what we would call an adaptation, but one thing that the maxillary sinuses do for us is that they change the sound of our voice. So the sinuses act actually as a resonating chamber that help change and louden our voices. So sort of like on a violin or a guitar, they have that big hollow wooden body that helps to the sound to resonate, helps to amplify it and change that sound. And that's what our paranasal sinuses do for us as well. So in addition to differences in the structure of our larynx or voice box, changes in or differences between individuals in our paranasal sinuses also helps to form the unique sound of our voices. And it also explains why when you have a cold, your voice sounds kind of funny. It's because those resonating chambers are now full, kind of like if you filled your guitar up with snot, right? Probably wouldn't sound as good. So the same thing happens to us when we have a cold. All right, so again, the paranasal sinuses are frontal, maxillary, sphenoid, and ethmoid. And these ones are in the midline, so we wouldn't say they were paired. These two are paired bilateral. All right, hope that helps you understand the paranasal sinuses, and I'll talk to you again soon.